Okay, let's jump right in. We are going to break down one of the most powerful and, let's be honest, most confusing parts of Node.js, the event loop.
So here's the big question, right? You always hear that Node.js is amazing at handling tons of simultaneous I/O. We're talking network requests, database queries, you name it. How on earth does it manage all that without just falling over?
And here's the kicker. It does all of this with just one single thread for your JavaScript. I know, that sounds completely backwards. How can one person, one thread, juggle thousands of tasks at once? Well, my friend, that is where the magic of the event loop comes into play.
To really get this, we've got to pull back the curtain on Node's big secret. It's all about a really clever division of labor. See, while it's totally true that your JavaScript code runs on that one single thread, Node.js isn't dumb. For the really heavy, time-consuming stuff, reading a big file or waiting for a network response, it offloads that work to the operating system's kernel, which actually is multi-threaded. Once the OS is finished with the task, it just taps Node on the shoulder and says, hey, I'm done. The event loop is the master conductor of this whole orchestra, deciding exactly when to run your code and when to wait.
So, let's try to build a simple mental model of how this all works. The very first piece of our puzzle is what I like to call the main to-do list. The technical term for it is the macro task queue.
Just think of a macro task as one item on a checklist. The event loop makes a full lap, grabs the next task from the top of the list, runs it, and then starts its lap all over again. Pretty simple so far. A perfect example of this is setTimeout. When you call it, you're not actually telling JavaScript to pause. No. What you're really doing is saying, hey, can you add this function to the to-do list and run it for me on a future lap of the event loop?
Now, if that were the entire story, this would be a very short explainer. But things are about to get a little more interesting, because it turns out some tasks get to cut to the front of the line. All right, pop quiz. Look at this code. We've got a setTimeout, which we now know schedules a macro task. And right after it, we have a resolved promise with a .then callback. So, which one do you think runs first?
I mean, based on our simple to-do list model, the setTimeout was scheduled first, so its task should get picked up on the very next lap. Seems logical, doesn't it?
And you'd be wrong. If you run this, the console actually prints promise first and then timeout. So what in the world is going on? Clearly, our model is missing a crucial piece.
And that missing piece is the microtask queue. You can think of this as the VIP express lane for really important jobs. After the current chunk of JavaScript finishes, the event loop basically says, whoa, hold on a sec. Before I even think about starting my next lap or grabbing another macro task, I have to check this VIP list and run everything on it until it's empty.
So what creates these VIP jobs? Well, you use them all the time. The most common ones are promise callbacks, so anything in a .then or a .catch. The await keyword too, which is just syntactic sugar for promises. And in the Node.js world, process.nextTick creates a microtask that's like super VIP with even higher priority.
Okay, so now we have this much better mental model, right? We've got a main to-do list and a high-priority express lane. Now, let's map that intuition onto the official, technical structure of the Node.js event loop.
So the loop isn't just one big circle. It's actually a cycle with these distinct phases, and each phase has its own little queue of macro tasks. It kicks off with the timers phase. That's where our setTimeout and setInterval callbacks get handled. It moves through a couple of internal phases before hitting the big one, the pull phase, which is the heart of I/O. Then you've got the check phase for setImmediate callbacks, and so on. But here is the most important part of this whole diagram. That microtask queue, our VIP express lane, gets checked and completely emptied after every single macro task from any of these phases. So, the loop runs a timer callback, then it empties the microtask queue. Then it runs an I/O callback, then it empties the microtask queue again. That priority is what guarantees our promise runs before our setTimeout.
Let's just zoom in on that pull phase for a second, because it's so important. This is really the workhorse of Node's async power. When your database query comes back or that file read is finally done, the callback gets queued up right here, ready to be executed. And this brings us to a classic Node.js brain teaser. A setTimeout with a 0 millisecond delay runs in the timers phase. setImmediate, however, runs in the check phase. Now here's the trick. The check phase is guaranteed to run immediately after the pull phase has finished its I/O callbacks. So if you absolutely need to run some code right after your I/O is done, setImmediate is a more reliable way to do it.
All right, theory's great, but let's talk about the real world. Why does any of this stuff actually matter when you're building an application? Well, It's everything.
I absolutely love this analogy from Jake Archibald. Blocking the event loop is just like a sneeze. When you run a long, synchronous task, that single thread is completely occupied. And just like when you sneeze, everything else, every other user request, every timer, every single thing comes to a dead stop. Your entire application becomes single-threaded in the worst possible way. Here is a perfect example of a sneeze in code. This while loop is a disaster. It does absolutely nothing but spin and burn CPU cycles for 5 straight seconds. Because it's synchronous, it completely hogs that one precious thread. While this one request is running, your server can't handle anything else. It's totally frozen.
And what does that look like on your server? Your CPU is going to spike to 100%, and your entire application will become completely unresponsive. To every other user trying to use your app, it might as well be offline.
So how do we keep all this straight? Well, here's a quick little cheat sheet for you. Set timeout and set immediate, those create your standard macro tasks. Promise callbacks and await, they create those high-priority micro tasks. Just knowing where things get scheduled can help you predict exactly how your code will run.
And the solutions are right here. First rule, always use the async versions of APIs for things like the file system or cryptography. If you have some seriously heavy, CPU-intensive math to do, don't do it on the main thread. Offload it to a worker thread. And for long calculations, you can even be clever and break them up into smaller chunks using set intermediate, which gives the event loop a chance to breathe in between.
And the performance difference is, well, it's not even a contest. A non-blocking server that plays nicely with the event loop can handle a huge volume of requests. But a blocking server with even just one of those sneeze endpoints will see its performance just fall off a cliff.
So I'll leave you with this question to think about. Every single synchronous operation in your code is a potential sneeze, a potential bottleneck. I want you to go look at your own projects and ask yourself, where are my sneezes? Where am I blocking the event loop and leaving performance on the table? Finding them is the first step to building a truly fast and scalable app.